In this video, we are going to talk about Le Chatelier's principle. Le Chatelier's principle predicts that a reaction at equilibrium will respond to a disturbance so that it counteracts the disturbance and reaches a new equilibrium. There are two different types of disturbances for chemical reactions: the addition or removal of a reactant or product, and the addition or removal of heat or a temperature change. These are very important in weak acid and weak base reactions. In biochemical pathways, reactions are approaching equilibrium and are continually adjusting to disturbances, particularly the concentration of hydronium ions, which naturally fluctuate as part of metabolism. At equilibrium, the forward and the reverse reaction rates are equal. The concentration of the reactants and products is constant, and the concentration of reactants is favored. If additional hydronium ions are added to a reaction, like in the reaction below, it is predicted that the reaction will shift to the left to consume the added hydronium ions until a new equilibrium is attained. So let's say we have this reaction of carbonic acid and water, and we add carbonic acid to water. It will start reacting until it gets to an equilibrium where the forward and reverse reactions rates are equal, the concentration of the reactants and products are constant, and the concentration of the reactants is favored. If we add more hydronium ions in there, we have now increased this concentration. Because we have an excess of H3O plus, we can now consume that, and it's going to drive the reaction to the left so that we can now use this new amount that we added and make more reactants, and it's said to shift to the left because you're going to the reverse direction towards the reactants. The rate of the reverse reaction is increased. So consider the reversible reaction of acetic acid and water below. We have acetic acid plus water makes hydronium ion and acetate ion. In this first example, would the removal of hydronium ions cause the reversible reaction to shift to the left or the right? So if we remove hydronium ions, so we decrease this concentration, we are going to shift the equilibrium to the right. We're going to shift it to the right because we want to restore this hydronium ion concentration back to where it was in equilibrium. If we remove some, we've now depleted it, and we need to get it back up to where it was before. So it's going to shift it to the right. That means that more reactants are going to react together to produce more products. So we're going to be producing more products. So the concentration of acetate ions is going to increase because it's a product. We're making more products. And how would the shift affect the concentration of acetic acid? Well, we're going to use up the reactants to make the products, so the acetic acid concentration is going to decrease. So the second situation, with the addition of acetic acid, so we increase acetic acid, cause a shift to the left or to the right for the forward reaction. So what would happen is if we add more reactant, we have a lot more reactant that we can use in this equation. So we're going to be able to use it in order to make more products. So it's going to go to the right. We are going to consume the acetic acid and make more product. So how would this shift affect the concentration of acetate ions? Well, acetate ions are a product, so it's going to increase because we are making more products. How would this shift affect the concentration of hydronium ions? Well, hydronium ions are products as well, so they're going to increase as well. So in summary, The Chateliers principle predicts how a weak acid or a weak base at equilibrium will shift, either left or right, to the reactants or to the products, forward or reverse reaction, when a reactant or product is added or removed. At equilibrium, the forward and the reverse reaction rates are equal, the concentration of reactants and products is constant, and the concentration of reactants is favored.